Hey guys, welcome back. Feature scaling, the secret to supercharge your machine learning model. We have already seen what is feature scaling in the previous video in the detail, what it means, what are the benefits of feature scaling. If you haven't watched the previous video, please go and watch that video first. In this particular video, we're gonna talk about how to perform feature scaling, that is hands-on, using Jupyter Notebook and the sci-kit-learn library. Just to give you a context, what is feature scaling? The scaling of features ensures that a feature with a relatively higher magnitude will not control the trained model. We want our algorithm to consider all the features with the same weight, with the same magnitude, right? And the magnitude should not have effect on the accuracy of the model. That's why feature scaling is important. So in this particular video, we're gonna see the different techniques for feature scaling, such as normalization and the standardization, and definitely min-max scaling. And we'll implement them using sci-kit-learn and the Jupyter Notebook. If you're new here, I'm a mentor in the field of AI and the machine learning. Started my journey 12 years back as a mentor, and during this time I got exposed to multiple technologies, starting from Java to DevOps to Python to data science and obviously AI. I have been helping corporates understand and implement the applications for the same. For now, let's focus on feature scaling, standardization and the normalization. Let's get started. Hey guys, welcome to AI with AI. This side Asif Imnad. Okay, now let's talk about the second type in feature scaling, which is normalization. So normalization is another star player, and this is widely used. So normalization squashes your features into fixed range between 0 to 1. You can define the range, but generally it is 0 to 1. Default is 0 to 1. So this is handy for algorithms that don't like huge outliers, such as some tree-based models and neural networks, right? So in simple words, normalization scales the variables between 0 to 1, okay? And this is how the equation for normalization looks like. X scaled, which is nothing but the values after normalization, performing min-max scaling. Each variable, which is input value x minus minimum of x, that is input, divided by max minus mean. Let's see the example here in the diagram. So again, we have prices given here in the column, right? Prices ranges between 20 to 200. Minimum is 20 and maximum is 200. And let's calculate the max is 200, minimum is 20. So the range becomes 200 minus 20, which is 180. So in the denominator, we need the range max minus min, right? Which is 200 minus 20, which is 180. And the actual variable minus minimum of input, which is nothing but here 100 minus 20, which is 80, divided by 180, which comes up to be 0.44. So this is how the values are getting calculated. Let's perform this for 20. So if I perform it for 20, 20 minus minimum 20, 20 minus 20 is 0. 0 divided by anything is 0, right? So that's why for 20 you see it is 0. Let's see the scaling for maximum value, which is 200 here. So 200 minus minimum, which is 20 again. So 200 minus 20 is 180. So 180 divided by 180 is 1, right? So for 200, the value becomes 1. And that's how min-max scaling works. So take away from this, the minimum and maximum value is between 0 and 1. Unlike standardization, mean can vary here, and also the variance can vary. Unlike standardization, in standardization mean remains constant, but here mean varies, right? Let's jump for the demo so that you understand in a better way.
Okay, before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you are watching our videos, but 90% are not yet subscribed. We put a lot of efforts creating these videos for you free. Keep us motivated by liking and subscribing, so YouTube algorithm will also help us reach more audience. So did you subscribe and like? Thank you.
So again, here back on the Jupyter Notebook, min-max scaler, that is normalization, squeezes the values between 0 and 1. This is the equation to calculate min-max. We already discussed it. So let's go for the next cell. We are doing the imports the way we did before, right? Same dataset, fetch California housing dataset to split the data into train and test. And the important statement is this, where we are importing min-max scaler from sklearn.preprocessing. Okay, let's load the data into X and Y using fetch California housing. Now let's describe the values. With the help of describe, I'll able to understand the statistical parameters of these variables, right? The way we did it for standardization. So I need to see mean, standard deviation, minimum value, maximum value, 75% of each value, so on and so forth, right? So here you see minimum value and the maximum value is quite different for each feature, right? Same for maximum, right? So the values are different. Remember, we are performing normalization here. So we are not looking for mean and the standard deviation, but we will be looking for minimum value and the maximum value. In normalization, mean can change and also the variance can also change. So we want to observe these mean value and the max value. So now let's perform standardization. Split the data into train and test, then perform min max scaling. We have initialized min max scaler here. Fit the data and perform the transform. So we are using one simple method which is transform here. Scalar.transform, xtrain, scalar.transform, xtest. If you want to see the maximum value and the minimum value, you can use scalar.data_max. These variables store the maximum values and min underscore scores the minimum value. So these are your maximum and these are your minimum values. You can also see the range, data range, which is nothing but max minus minimum, right? And now the important thing that we need to perform is describe. Now let's describe the data to see the statistical parameters of every feature. And we are performing this time on the scaled data and not on the original data. Okay, so this is our scaled data after performing scaling. So this is our original data after performing scaling. Let's see how does the data looks like now. So if you see, mean is not set to 0, unlike standardization. In standardization, mean set to 0. And standard deviation is also varies. Standard deviation in case of standardization, it is 1. The important point that we are looking for here, the minimum value and the maximum value. So if you see, minimum value is 0 in every feature and the maximum value is also 1. So minimum and maximum range is in between 0 and 1. So if you see, every feature which you see here is ranged between 0 and 1. Amazing, right? And let's see the histogram just to see the distribution. So this is on X train before performing scaling. Look at the distribution, right? And this is after performing scaling, that is normalization. Okay, the distribution doesn't really change. The important thing that you need to note here, the value ranges between 0 to 1, 0 to 1, 0 to 1. For each and every feature, values are squeezed between 0 to 1, right? This is the reason why we use normalization. Distributions doesn't changes, but we keep the values in between certain range to normalize their magnitudes, right? Now let's perform the same thing on the real data sets so that you can practically visualize and practically see what happens after standardization and normalization. Okay, so we are performing feature scaling on the wine data set here, and to do that, I'm importing wine data, right? pd.read csv. The data set is available under this directory, and let's see the head. Okay, so we are looking for only 3 columns currently: class label, the type of wine, alcohol content and the malic acid content, alcohol content and the malic acid content here. All right, now let's apply the standardization on this data by using pre-processing, standard scalar, fit, alcohol and malic acid. So I want to perform standardization and also do the training on both the columns, alcohol and the malic acid, and finally perform the transformation by using transform function here. So what we are looking for here is mean after standardization. If you see, mean after standardization becomes 0, 0 for alcohol and malic acid, right? And we also want to see the standard deviation after performing standardization. So the standard deviation becomes 1, right? Mean to 0, standard deviation is 1. That is the effect of standardization. We have been talking about this again and again. Now let's perform min max scalar as well. Wait till the end, we are going to visualize this as well. Okay, and to perform min max scalar, I have initialized min max scalar, perform data.fit, alcohol and malic acid, and finally again use transform. Nothing different. In min max scalar, we are interested into minimum value and the maximum value and not the mean and the standard deviation. We are looking for minimum value and the maximum value here. Okay, so minimum value is 0, 0 and the maximum value is 1. Beautiful. The difference we are going to see after plotting. So you will able to see here how does the data look like before performing standardization and after performing standardization on the same data, and also after performing min max scalar. Okay, so let's plot the data. So we are plotting scatter plot here. Okay, if you observe, we are plotting the scatter plot For the original data set first, DF alcohol, DF malic acid, we are plotting a scatter plot again on standardized data, and we are also plotting a scatter plot after performing min-max scalar. So we should have 3 plots on original data first, after performing standardization, and after performing normalization, which is min-max scaling. And let's add the title, labels, regions, and plot the data scatter plot here. If you see, this is a really wonderful plot I can see here. Let me zoom out a bit so that you can see it properly. If you see, green one, which we have plotted, color green, right, on original data set, if you see, this is where you can see the scatter plot. The mean is not at 0, the values are not in between some specific range, and the scatter plot looks somewhere away in the plot, right? So this is how it looks like without performing any scaling. But if you see the pink and the blue one, after performing standardization, mean became 0 and deviation became 1, 0 to 1, 0 to 1. This is the effect of standardization. These are same data sets. These are not different data sets, okay? So we perform scaling on the same data sets here. But here we are visualizing it just to understand their nature. Their nature doesn't really change. Distribution doesn't really change. After performing min-max scaling, you can see 0 to 1. The value ranged between 0 to 1 on x-axis and also on the y-axis. That's the benefit of performing feature scaling. Beautiful, isn't it?
And that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit the like button, and don't forget to share this video with your friends and the colleagues. Thanks for watching. See you again next time. Till then, take care and bye bye.